Hello geometry students, we are finishing up 10.7, which was all about pyramids and cones. And what we're actually going to focus on today is not just pyramids and cones, but we will be just doing two different composite figure problems. So just more examples involving 10.6 and 10.7, although I'm just going to call it 10.7. So we're going to do two examples, both of them being composite figures. The first example is kind of hard to explain, but what we are going to draw is a rectangular prism with a cylinder that's cut in half and stuck to it. So I'm going to show you just a little bit about what that's going to look like. So that is the front, or that front face of the two shapes. So I have a rectangular prism that's going to be on top, and I'm going to try my best to kind of do this like I'm going to do it like that right away. I'm going to make another the back face of the cylinder, and I think that if I finish that off like that, that might be a good 3D shape. Not the best I've made, but hey, not the worst. So let's mark all of these things. This front face right here is 16 meters, the distance between the left side and the right side. This long side right here, it's actually going to end up being the 20, I don't even know what I was saying. The 20 meters is going to end up being the height of that half cylinder. This little height of the prism is 15 meters. And that is all the information you need. And I'm going to show you why that's enough information. So just like when we've been doing composite figures, well, what we did last time was we had a composite figure here and we kind of drew out both textures. I'm going to do a very similar thing here. So down below, I'm going to do two different pieces. Down below, I'm going to have a rectangular prism, 16, well, that's not great, 20 and 15. So behind there, I'm going to draw that 3D piece because I need the area of the base. And my volume is the area of the base times the height. Well, I know what the height is. The height is 15 from the base to the top there. And then I'm looking for the area of the base. The area of the base is a rectangle, and so that is just 20 times 16. And 20 times 16 is 320. Multiply those two numbers together and you get 4,800 meters cubed. But I'm going to leave off the units there because we're going to do the units at the very end. So because volume is so easy, we can just find the volume, add it up. We don't have to do any weird subtractions. We don't need to piecemeal things together. That's going to be great. There you go. That makes it a little bit better for that 3D shape. Okay, so we have our half a cylinder. So the volume for a cylinder is pi r squared times the height. We can look at that here. So the volume of the cylinder is pi r squared times the height, but we only want half of it. So we have 1/2 pi r squared times the height. And that 1/2 is not part of the formula. I want to remind you, it's not part of the formula. It's only because we have literally half of the cylinder. So we have half the cylinder there. 1/2 pi, what's the radius? Ooh, what's the radius of this circle? We know the diameter is 16. So the radius is half of that, that's 8. So even though it didn't actually say like this is the radius, it gave us enough information. So I'm going to plug that all in my calculator. If I asked for the exact answer, you could give me 640 pi. But if you type that in your calculator even further, you get 2010.619 something. I have those two values. Volume is super nice because I can just add them up. 2010.619 plus 4,800. Plug that all in your calculator and you're going to get your final volume, which is 6,810.619 meters cubed, because we are talking about volume. So we were able to kind of piece those two things together with really bad 3D drawings. pause the video here if you need some time to write that down or copy things out or say, hey, I don't understand it, let me email her. And we'll go down to example 2. Okay, easier to draw. We want a cone on top of a cylinder. So I'm going to draw the cone first, because that actually ends up being easier, because then we can just add the cylinder on the bottom. So take a second to draw that out. Definitely not drawn to scale now that I look at the numbers that I'm going to use. The diameter is 12. The height is 10. See, already not drawn to scale. And this slant height is 8. That's a really bad 8. How would I do that? And so I will say, when we look at our formula sheet and I'm looking for the volume of a cone, I'm not going to want the slant height. The slant height I can use for the surface area, but I don't need the slant height for the volume. I need the height, so we'll actually have to find the height because that's not given to us. But we're going to piece this together. So I have the cone. Not enough information is given to me. I'm going to have to figure that out. What is the radius, though? Well, if the whole diameter is 12, the radius is 6, and I need my height. And so I'm only going to set this up right now because I want you to recognize that 8 and 6 are not both legs. 8 is the hypotenuse, and we're looking for the height. We're looking for this x value here. So I'm going to solve that, subtract 6 squared from both sides, and x is 5 I'll round it to 2.291. So that's my height. So I can use that. The volume of that cone is pi r squared. Oh, it's 1/3. Oops, totally forgot. It is 1/3 pi r squared times the height. And I know the height because I just found the height, otherwise I wouldn't know the height. But that is, let me fill that all in, 1/3, whoopsies, pi, what's my radius? 6 squared, what's my height? 5.29, I guess it's technically 2 when you round it. Yeah, let's leave it as a 2. Whoopsies, it was 0.15. Okay, so I have everything. I'm just going to plug that all in my calculator. You could come up with a really nice pi value if you wanted to, but it would still be rounded because that's rounded. So I would just type it all in your calculator. You get 199.503 units cubed, but we're not done yet, so I'm just going to leave that hanging out right there. And we are going to do the cylinder next. So we got to find the volume of the cylinder. The volume of the cylinder, I'm not going to redraw it, I know. The volume of cylinder is pi r squared times the height. Pi, what's my radius? Well, it's half of 12, or half the diameter, which is 6, squared times the height, which is 10. Well, that's much easier. Just type that in your calculator. Maybe you don't even have to. 6 squared is 36, times 10 is 360. Pi, I mean, I would rather type that into my calculator and add it up to that versus type that in my calculator, get an answer, and then add it up to 199.503, but you don't have to. So I'm going to take both of those answers, plug them in my calculator. If you are using a calculator that doesn't have a pi button, type in 3.1415926. Don't actually type in 3.1 or 3.14 because that's not going to give you a rounded answer that's close enough. You add it all up and you get 1,330.477, which would actually be like 0.5 if I asked you to round to the nearest tenth, units cubed.